Hello, everyone, and welcome back. Today, we are going to be doing our first day of our last unit, Unit 6. This unit is all about trigonometric functions. In this unit, we are going to cover the trigonometric ratios of acute angles and finding the trigonometric ratios of acute angles, finding angles of a right triangle, and also finding sides of a right triangle. I think for a lot of people, this will be a review from grade 10. So if this is something you're already familiar with, then feel free to jump ahead to day 3, which is the sine law, and day 4, which is the cosine law. For a few people, sine law and cosine law may also be review from grade 10, or you may be someone in a grade 10 course who is watching this to learn about these things, and that's fine as well. Day 5, we're going to introduce periodic functions. So we're going to introduce what does the graph y equals sine x and the graph y equals cosine x look like. If you're looking for y equals tangent x, that will not be covered at this time in this unit. And then we have day 6, which is the graphing the transformations of sinusoidal functions, and then day 7 about sinusoidal models. So about half this unit is trigonometry, and about half of it is sinusoidal functions. So actually being able to draw the graph and learning the characteristics of those graphs, all of that kind of stuff. All right, so let's go ahead and get into it. Oh, and I should mention for the sine law and cosine law, there will also be word problems related to both of those topics in this unit. So let's go ahead and get started with today's topic, which is all about finding the sides and the angles of a right triangle. I think we're going to put those into one day because those are very similar. So basically, an area of mathematics that examines the relationship between the angles and sides of the triangle. So using basic trigonometric ratios, we can do that for all right triangles. So I'm going to quickly review the basic 3 trig ratios. So we have sine, we have cosine, and we have tangent. Now, sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Some people like to use a mnemonic device that goes so, ka, toa, right? In order to remember that S for sine, right? S for sine is equal to opposite, so O over H. Cosine, so C, is equal to adjacent over hypotenuse. And TOA, tangent, is equal to opposite over adjacent. So I'm going to talk about how do we know what's what. So the hypotenuse is fairly obvious because the hypotenuse is the same for all triangles. The hypotenuse is always the longest side of a right angled triangle, and it's also always the side that is opposite of the 90-degree angle. So notice here's our 90-degree angle. This is opposite of the 90-degree angle. When we're talking about using the basic trigonometric ratios, we're talking about taking this angle, let's say this is angle theta, or the other one could be angle theta, and looking at it from this perspective. Okay? So basically, if this is our angle, then the adjacent to this angle, adjacent is this one here, right? It's the adjacent or the beside side. And then the opposite, the one that isn't touching either of the legs of this angle, is this one. This one is O for opposite. But notice how, let's say I decide that this is angle alpha, and I would like to find sine of alpha, for example. Well, now the opposite is this one over here, and the adjacent is this one over here because we're choosing a different angle. So opposite and adjacent are different, is something I want to stress to you guys. Opposite and adjacent, can swap depending on which angle we're looking at, right? If I was to give you this triangle and say, okay, tell me what's the hypotenuse, what's the opposite, and what's the adjacent, you'd probably tell me, okay, well, here's the hypotenuse, it's this line here. But in terms of which one is the opposite or adjacent, you'd probably need to ask, well, which angle are you referring to? Because if it's this angle, then here we have our opposite and here we have our adjacent. But if it's this angle, then here's our adjacent, and this is our opposite. So it just depends. And that's something that confuses a lot of people. They think, oh, this one was used as the opposite side in this example, so therefore it will be in the next example. And that's not the case. However, that will always be the case for the hypotenuse. So that's something I wanted to make sure we understand and really clarify there, because that's a common mistake I see. All right. Now, what about reciprocal trigonometric ratios? So basically, there's three reciprocal trigonometric ratios I'll go over. These ones are honestly not that useful and will not be used that much, but it is still good to know them because they may come up on a test, or they may come up later when we talk about trigonometric identities in a future course. So reciprocal trigonometric ratios. So the reciprocal of sine is cosine, or cosecant, CSC theta is equal to hypotenuse over opposite. So notice all I did is I took the reciprocal, I switched the O and the H. Now it's hypotenuse over opposite rather than opposite over hypotenuse. The reciprocal trigonometric ratio for cosine is the secant, and that's going to be the hypotenuse over the adjacent, right? So I switch them. And then for tangent, it's going to be cotangent. And that's going to be adjacent over opposite. So I switch them again. So CSC is related to sine. Secant is related to cosine. And cotangent is related to the tangent. So it's good to take note of these. However, these aren't really, solving wise, these aren't necessarily as crucial, but still is important to know them. They're just not as important as the primary trig ratios. All right, so now I'm going to go ahead and find the following values. So for this, you're going to grab your calculator, and we're going to punch in the following values into our calculator, because not all these values we can figure out through methods that we know just yet. So let's start with sine 40. Make sure that your calculator is in degree mode. It should say DEG at the top. If it says RAD or something else, then that is a problem. It will not give you the right answer in terms of degrees. So unless you're wanting to do radians or some other form of measure, make sure you have the degree symbol at the top and that you're getting degrees. Okay, so first one is sine 40. So find the sine button and then 40 and press enter. And then that is going to give us 0.6427 and then some other numbers. I'm going to just round to 2 decimal places, so 0.64, like that. Okay. Now let's try the next one, cos 50. So type cos and then 50. And that is going to also be 0.64. Now, let's talk about why those are the exact same number. Let's talk briefly about that, because if we have a triangle that has the degrees like this, let's say this is 40 degrees and here's our 90, and then this angle is something else actually that I should be able to figure out given the information we know. Actually, let's make this one 50. Yeah, this one looks a bit bigger. Let's make this one 50 and this one 40 degrees. And that makes good sense. You know, if we take the sine of 40 degrees, then that's taking the opposite over the hypotenuse. Well, that opposite over hypotenuse is equal to, if we're looking at this one, 50, the adjacent over the same hypotenuse in this case, because now we're looking at it from the perspective of a different angle. And so of course, it is going to give us the same thing if we think of it that way. So that is why we got the exact same answer. We did not do anything wrong. It is good that we got the same answer for both of these. So that's why. Now, we don't know what O and H are, right? This could be, this triangle could be infinitely an infinite many triangles. But what we do definitely know for sure is that this triangle has the same ratios no matter what. So whether we scale it up, scale it down, whatever, the ratios are still the same, even though we don't know the exact values. We just know kind of the proportion of the values, that when we take this side and divide it by this side, no matter what the actual numbers are, we will always get 0.6427, etc. Right? So that's pretty cool. That's pretty cool. And so, no, we are not in trouble for getting the same answer twice. We were supposed to get that. Okay, so next let's find the cotangent of 30. So to do this, since it's the cotangent, not the tangent, we're going to type into our calculator 1 divided by tangent of 30. So 1 divided by tan 30 is what we want. We're going to get 1, oh, oops, wrong color. We want black, not blue. 1.73. Now, one mistake I often see students make is they think that the reciprocal of tangent, so the inverse tangent, is the same as cotangent. This is not the case. Notice if I press second function tangent and get tan, inverse tan, and then put in 30 degrees, I'm going to end up with, from this, I don't know how well you guys can see that, I'm going to end up with 88.09. I end up with a completely different answer. So make sure that for finding these, even though we don't have any cotangent buttons on our device, we can use 1 divided by tan 30, and that will get us the correct answer. And this is, fun fact, this is root 3. Right? This is actually root 3. If we type in root 3, it's the same thing. We'll learn why it's root 3 in a future year, but this is exactly root 3, cotangent of 30. For secant of 60, well, secant is associated with cosine, so we're going to say 1 divided by cosine of 60 is equal to blank, and we end up getting 2. So the secant of 60 degrees is equal to 2. Very good. All right, let's move on. Here we're being asked to find the value of x. Okay, find the value of x. So here we have 75 degrees, and we want to find x. And x is the adjacent of the 75 degrees, so I'm going to write that we need to find the adjacent. Right? Or I'll just put A for adjacent, actually. And we have the hypotenuse, right? We can see that 250 is clearly the longest side here, and it is also clearly the opposite of our right angle. So therefore, we have the hypotenuse. So what's trig ratio has to do with the adjacent and the hypotenuse? Well, let's see. So for sine, well, no, that's not quite right. Ka, oh, yep, that's right. And then toa, definitely not. So cosine is what we're going to use because cosine is adjacent over hypotenuse. So let's do it. Cosine of 75 degrees is equal to the adjacent, which is x, over the hypotenuse, which is 250. Then I'm going to multiply up. I'm going to cross multiply up that 250 to cosine 75 degrees. X is equal to 250 cosine of 75 degrees. And what I'm going to do now is I'm going to type into my calculator 250 times cosine 75 is equal to what? And I end up with 64.7. I am rounding. It actually is a full calculator full of numbers, but I'm just going to round to 1 decimal place in this situation, or you could even round to 65 if you wanted, because their numbers were rounded to, we're free of decimals, but I am going to round to 1 here in this case. Or even if we were rounding to 2, it actually would be 70 would be what we'd round to, so that works that way as well. So the value of x is 64.7. So you see the process there, where we had to first figure out which ratio to use. So step 1 is find the ratio. Find the correct ratio. And when I say ratio, I mean sine, cosine, and tangent. Those are all ratios. Number 2 is to apply the ratio. So that's a step where we plug in the numbers. And then step 3 is to solve. So that would be like here and here where we solved, and we plugged in the numbers into the calculator and got the answer. Now, the other thing is, let's say we get a very outlandish number. If we get a very, very small number here, that's probably not really the case. If we're being honest, right? And also, if we get a large number that's really, really close to, in this case, given how the triangle looks, or a number that is greater than 250, we know we definitely have it wrong. Something I do want to point out here about this drawing is this isn't really to scale. If we think about, this looks like a smaller angle than a 45-degree angle, and it's saying it's 75. And so this isn't really to scale. So the fact that this looks to me, more than half of 250 doesn't actually matter, because I feel that this is a very poor drawing and isn't really drawn to scale very much. If we think about a 75-degree angle, it would be closer to 90 than what it looks like. So I do want us to ignore that it's not to scale. However, if you do get an answer that is greater than your hypotenuse or equal to your hypotenuse, definitely be wary, then it is probably incorrect. All right, let's try this next example here. This one actually does look a bit more to scale to me. Yeah, because then this would be 30, so this would be the smaller angle. Or sorry, this would be 40, so this would be the smaller angle. So this actually looks a little closer to scale to me than the last one did, which is good. So let's find the value of x. So here we have the opposite, and we need to find the adjacent. So tan deals with that, right? Tangent theta is equal to the opposite over the adjacent. So that is perfect for us. So let's plug in tan 50 degrees is equal to the opposite, which we said was 312, over the adjacent, which is x. Okay, next I'm going to swap x and tan 50. So I'm going to cross multiply the x over to the left and cross multiply the tan 50 down to the right. So x is equal to 312 divided by tan 50. And let's find out what that is. And again, we are expecting this, to be a bit less than 312 still. Even though 312 is not the hypotenuse in this case, given where the angles are, that would make sense. So let's put that in. 312 divided by tan 50 is equal to 261.799, which I'm just going to round to 261.8. And so that is going to be our final answer, and that makes sense with kind of what we're guesstimating there. So that's really good. All right. Let's move on to example 4. Example 4, we have this angle is 33 degrees, and we would like to know what is x. So we need to find the hypotenuse, and we have the opposite. We don't have or need the adjacent. So we need to use a ratio that we haven't used yet, and that has opposite and hypotenuse. So that would be the sine ratio, right? So sine of angle theta is equal to opposite over hypotenuse. So now I'm going to plug in my values. In this case, it's sine of 33 degrees is equal to opposite, which is 408, over hypotenuse, which is x in this case. So then I'm going to swap the x and the sine 33 and get that x is equal to 408 over sine 33 degrees. And this means that x is equal to, well, let's check our calculator. We're going to punch in 408 divided by sine 33 is equal to 749.1 approximately. Again, we got a calculator full of digits. I'm going to round to one decimal place in this case, but do round to whatever your teacher prefers. All right, well, there we go. There we have it. We figured it out. All right, so that is everything for lesson 1. The next lesson is lesson 2, and that will have to do with the sine law. So I will see everybody back to learn about the sine law next time. Have a good day, everyone, and we will see you next time to talk about the sine law.